All right, so some quick reminders about when we're looking at linear, quadratic, and exponential functions. What do we observe in the equations and the graphs and the tables and the domain and the range and so on? Right, this is kind of what the quiz is on. Okay, so for linear equations, the key is we're always going to look at the exponent. Okay, so we're always looking at the exponent. Okay, linear equations have no exponent. They have no exponent. So for example, y equals 4x plus 7. That's linear. That's called slope-intercept form. Linear equations also sometimes are in standard form. They might look like this. Okay, those are both linear equations. Quadratic equations have an exponent of 2. This is what quadratic means, that the equation is exponent of 2. So it can just be something simple like this, y equals x squared. It can also be y equals 4x squared minus 5x plus 7, something like that. But what we're looking for is this exponent of 2. And exponential equations, what makes them exponential is that they have an exponent of x. Okay, so for example, this is like y equals 4 to the x. Like that's a very basic exponential equation. They can also be like this with more stuff, but no matter what, the exponent is x. That's what makes an equation exponential. So when we have these equations and then we create the graphs by graphing, the x and the y values, linear equations, the graphs are always going to be straight lines, right? Like that's why it is called linear, because it's a line. Okay, quadratic equations always have this parabola shape. Okay, remember it's called a parabola. But it's that U shape, and what really helps is to just remember, like, it's always QU, quadratic, right? So it's always that U shape. And then exponential graphs, they have graphs that look like this, where they're growing slowly, and then they grow really fast, okay? And sometimes, we haven't talked about these too much in Algebra 1, but sometimes they go down like this, but they're that kind of curved shape, that exponential graph. Okay, when we look at tables, what happens with tables with an equation like this is like, if x goes up by 1, then I would just add 4, right? Add 4, add 4. So with tables, I'm adding in each row. So for example, like a table, right? Let's say the x values are 1, 2, 3. This table might be like, let's say I'm adding 5. So like I start 4, and then I add 5, that's 9. Then I add 5, that's 14, right? That's plus 5, okay? Plus 5. Okay, now look, I'm going to skip quadratic for a second. I'm going to come here to exponential. In exponential, we're multiplying in each row. So now, let's say I have a table that looks like this. Let's say this starts at 4 again. Now, let's say I'm multiplying by 3, right? So that would be 12. And then the next row, I'm multiplying by 3 again. That's 36. Okay, so exponential multiplying. Linear adding, like honestly quadratic, it's like the other one. Like find the one that's adding in each row, find the one that's multiplying in each row. The quadratic is the other one, okay? Now, domain and range can be tricky. I will tell you for all of the functions that we have studied, now look, this is not always true, but all the functions we've studied so far, look, this line goes forever to the left, forever to the right. This parabola goes up and left forever, up and right forever. Look, this goes forever to the left, this goes up and right forever. So for all of our functions that we've studied so far, our domain is all real numbers, okay? The domain, the x values can be anything. They're going all the way to the left and all the way to the right forever and ever and ever. Now, the range is where these functions are a little bit different. For linear functions, they also go down forever and up forever. So the range is also all real numbers. The y values can be anything. For quadratic functions, my ranges are like y is greater than or equal to a number, y is less than or equal to a number, but it's or equal to, because whatever, like let's say right here, this y value is 0, it includes 0. So if I were to say, and a lot of times what we look at is we look at this called parent function, right? This parabola that touches 0, right? This would be all positive numbers. This would be y is greater than or equal to 0. That's all positive numbers, and it includes 0. This one includes 0. However, if I have a graph like this, an exponential graph, and this is what's tricky because it kind of looks like it touches the x-axis, but it doesn't. It actually sits just above the x-axis. So these ranges are more like y is greater than 0, y is less than 0, but it doesn't touch 0. So a range for an exponential graph might look like something like all positive numbers, but it wouldn't include 0. Okay, it doesn't include 0 because look, this graph actually doesn't touch 0. Okay, so those are just some examples. All right, now some just reminders about domain and range. When you're giving a domain and range, domain is always left to right. Okay, it's x value. So the domain, you would always be looking at only this axis, and you'd be looking at the left x value and the right x value. X, not y. So you're only looking at this axis. And when we talk about where a graph is increasing, where it's going up, and where it's decreasing, where it's going down, we also use x values. So once again, it's always left to right. A common mistake on the quiz was people put right to left, and it's wrong. They got both wrong, okay? So remember, it's always left to right. And then the range, for the range, you're looking only at the y value. So only at this axis, only at the y-axis. And the range must be bottom to top, okay? It can't be top to bottom. It'll be wrong. You got to start at the bottom of the graph, get the y value, and then go to the top of the graph, get the y value off of this line, okay? There was a couple other items on the quiz. If I'm going to fill out a function table like this, look, I'm plugging in. So f of x is 2x minus 4, right? F of x is 2x minus 4. Here, if I plug in 0, that's 2 times 0, that's 0, minus 4, I get negative 4. This would be 2 times 1 minus 4, that's 2 times 1, that's 2 minus 4, that's negative 2. Okay, now here, look, this is 4 to the power of x, 4 to the power of x. So what's 4 to the power of 0? Anything to the power of 0, anything to the power of 0 is 1. Okay, anything to the power of 0, any number to the power of 0 is 1. Always. And then 4 to the power of 1, any number to the power of 1 is just that same number, 4. Okay, and then to fill in this one, what I want to know is what value of x would make this equal to 6, right? Like what value of x could I put in those parentheses that would make this equal 6? So I can solve this equation. I can also ask myself the question, what value of x would make 4 to the power of x equal 1024? Now, you can solve this. You could put this in your calculator and just do 4 times 4 times until you get to 1024. You could do that. I think it's probably easier to solve this because this is very familiar to you. Divide by 2, I get x equals 5. And then what I would do is I would just put in my calculator 4 times 4 times 4 times 4 times 4, 5 times, and just make sure it equals that. And it does, okay? 4 to the 5th does equal 1024, okay? So then I would put 5 here, right? The x value of 5 would get me a 6 in this function and a 1024 in that function. The final thing that I want you to be aware of for this quiz, sometimes when you're asked what equation does the graph show, and we're talking on the quiz, it looks like this, it's an exponential graph. And so you know, oh, it's going to be an exponential function, but which one is it? Is it y equals 2 to the x, y equals 3 to the x, y equals 4 to the x? The key is to just check right here at x equals 1 and see what's the y value. Let's say the y value is 3, right? That would tell you that it's this function because look, here's the x. So if I plug in 1 for x, look, if it was 2 to the 1, I would get 2. If the equation that the graph shows is 3 to the x power, I would get 3 to the 1 is 3. 4 to the 1 is 4, 5 to the 1 is 5, and so on. So if I'm wondering, what equation does this graph show? What I'll do, and I see it's exponential, so I know it's like one of these guys, I would go and see, okay, what is the y value when x equals 1? Okay, so that's a tip for that.